So good morning to everyone. I'm a metrologist, so a little bit outside the community of automotive, but actually I started my work in the automotive community. And what I would like to present you, it's a flipped approach toward the requirement for ADAS sensing. And to do this, I would like to explore with you the past and the future, because they are absolutely connected through photometry, the standards about the road environment, and as well detector performances and the drivers we have. And this connection evolved through a straight line, but now we are in a discontinuity. And what I would like to propose you is this flipped approach toward the future. We started at the beginning of the 20th century with automotive, but as well, the photometry started on the same time. At that time, the challenge was to define how people perceive the light, because we needed there and now to measure light, that is an electromagnetic wavelength that the human perceived. And the challenge was to measure how human perceived light. And so CIE, the International Lighting Community, it's a scientific organization that was born in France, maybe more or less at that time. They define the V lambda. That is a concept that we still use, and also some detectors refer to measure light. But on the same time, beginning of the 20th century, they started with the approach of luminance concept on road lighting, on road, and visual contrast in order to perceive objects or cats on road. The evolution moved forward. They try to not work on road lighting only, but to improve the performances of lighting system of cars. And again, in the 1952, it started the idea of an observer framing the road in a given geometrical condition. And this observer was absolutely a human being. And this human being framed the road more or less 200 meters far away. Then the evolution is up to the standard. The European one is about considering an observer at 1 meter and 50 high, so sitting in a car, framing the road at a given distance that must more or less start at 60 meters. It means that that observer, a human being, represented by V lambda, observed the road with 1 degree of observation. And all this is to define the reference observer for road lighting. All requirements are about a given geometrical condition and a given spectral sensitivity, that is the human sensitivity. Regarding artifact in road lighting, road marking, signal, road lighting as well, again, based on the performances of CIE reference observer, it was defined a reference observer for road characterization that again is framing the road at one degree of observation with the same human sensitivity. While for road marking or as well retroreflector, the requirement changed a little. The observer is no longer at 1 meter and 50 high, but it's lower, 1 meter and 20. It means that, again, the reference observer for photometry of CIE is seeing the road at 2 degrees 29. But since all these artifacts have also some color, it was needed to refer to the colorimetric CIE reference observer that describe and enable us to measure the color as the human perceive. Because color is just perceived by human when there is light. And it depends on the different behavior in reflectance, wavelength by wavelength, of the material. And so CIE defined this region that you know very well, in order to understand or to ensure that people, even with small disability in color perception, can perceive red, green, blue, and so on. But what is the target? The target is not to perceive the green or the red. The target is to understand the semantic meaning of this color. Then we have the camera. And the camera needs to follow the human perception of color in order to produce very good picture. But as well, the camera needs to understand the color on road. And so they refer to the human being. Currently, all cameras evolved based on human performances and as well on this reference observer. By this way, we can you define as well, some KPI, and obviously the best KPI is the one that follows perfectly the reference observer we have. For a reference observer about photometry, there is a parameter, a KPI, that is called F1 prime, that describes how well the detector followed the reference observer for photometry. But now, we are no longer only human driver. So everything, all the reference standards have been built with the approach that it's a human driving, sitting in a car, framing the road 1.50 meters high or 1.20 meters, and with a given sensibility, spectral sensitivity. But it's no longer true. And so we have new drivers, new observer, and new need. And what we are doing, we bend sensor performances, material signaling, and so on, everything, to human limitation or to human perception. And some very nice people, some good fellow and a lady, believe that photometry is a limiting factor for high-resolution application, and as well, color sensitivity application, because the target is not the color. The target is the semantic meaning of that color. And so with the Bellaroma group, we move toward a non-biological reference observer. So it's a flipped approach. Instead of bending the sensor to the current reference observer as required by all standards, the challenge is to define a new biological reference, non-biological reference observer, especially for automotive computer vision applications. This will help absolutely to develop better sensor and better metrics, better KPI in order to understand sensor performances. So we already published a paper, and we started an activity at normative level at CIE, in the same organization that define all the reference observer we are currently using to define a new reference observer non-biological. The details, we have just a rough view. Obviously, it will be a digital, it will be radiometric and non-limited to visible, because there's no necessary to stop to the visible range. In this research forum, everyone can join. We need as well some manufacturer, different expertise, in order to find the best reference observer agreed by all different parties. And just to provide you some idea on how this new reference observer will work. How to measure the color, obviously human. We have a light source in the visible spectrum. We have a material that has a physical characteristic that is called spectral reflectance, that describe how the material reflect or absorb and reflect, so modify the incident light. And then we have the reference observer for colorimetry. We do some math, and ta-da, we have the color value that you are looking for in your road environment. But the target is, again, the semantic meaning. So if we are looking at the non-biological point of view, the non-biological point of view, this diagram is no longer useful. As well, this reference observer, we need a new one. We need to characterize the material not only on the visible range, but on the extended range, because our sensor works also over the visible range. And we need a light, again, over the visible range. And we have a lot of room to look for these new different performances. And we started doing some research with the road marking, different color of road marking. So for human, we are here. This is the human perception. You saw some white, yellow, two kind of yellow, one green, and so here we are. This is the characterization in the visible spectrum of the different road marking color, and you perceive absolutely different graph. Then, in the center is the maximum sensibility of human being, so the V lambda. If we extend, you can see the shape are more or less the same, because it means that the ink, the dye they used are to provide just the color. And so there's a lot of room to put something here at the manufacturing stage in order to transfer the semantic meaning. We do not longer do calculation just only here, because sensors maybe can perform better there. And if at the manufacturing level, we can put a signature, and we can add as well as a reference observer that enable us to do some math as we do here, but also here, we can better understand the semantic meaning. So the impact, we hope, will be huge. And it will be maybe a new way to design or optimize the sensor, ensure product comparison. But what I would like to stress is that it's a pre-competitive research. And it will help to reach a safer road environment and safer automotive. But there is a good news. This research forum and the Bellaroma group welcome you this afternoon in room, oh my God, in room 1 here, because we will have a first meeting and everyone can join, especially because the CIE organization is absolutely open to all interested parties. And let's say it's really, I hope, a good occasion to build something new and to change the approach toward the road characterization, the road driving, and sensors. So I hope to see all of you there at 4:30.
Let's see if there are some questions.
Sure.
All right, any questions? No questions?
I hope all questions in room 1.
Thank you for the nice talk. So you talked mostly about color and moving, maybe observing the unused parts of the color in the future. Have you also thought about maybe the structure? So maybe instead of using numbers which have to be parsed, you could use some kind of maybe QR codes or some other kind of markers that computers can see better. So maybe that could be an improvement for computer vision.
So you talk about put some QR code on the, everything is possible. Let's say is it cost efficiency related as well, but maybe the QR code can be just a signature of a given wavelength. But again, if we look at the sensors, I guess it costs a lot to produce a sensor with a given wavelength sensitivity. But since the idea is that the reference observer can be digital, again, we can do a lot. So we have plenty of different possibilities, because we have to say that color doesn't exist only for human. For the physics, it exists the behavior among the material and the light or the electromagnetic wavelength. That's all. And we have to play with that. Instead, to play with the human perception that it's actually a challenge to reach the same human perception.
Great. Great. Any other questions? All right, well,
All right.
let's thank our speaker.
Thank you.